a net, and still have adequate immune protection, but may be able to reduce autoreactivity and inflammation. So
Right.
I don't know if you read about adenosine and its various anti-inflammatory, adenosine and adenosine agonists, and how they inhibit, for example, neutrophils, but they also inhibit T cells, lymphocytes.
No, I'll definitely look into that. And then even going beyond small molecules, biologics, and steroids, which are kind of the standard. Looking beyond that, do you think there are any technologies that are of interest to you, that beyond even, so you mentioned CAR T, and that could be a really exciting opportunity, but is there interest around things like stem cells, or also one technology we've seen is basically similar to pheresis in the sense that you have a nanoparticle that can clear autoantibodies from circulation. What's your perspective on therapies like that?
Quickly, I just want to go back to DNAase. So, I know some scientists that study DNAase and maybe polymorphisms of DNAase are problematic and may, promote persistence of DNA in a manner that is more autoreactive, and therefore a therapy might be, to infuse or provide. The idea of eliminating DNA, which is, a potential autoantigen, I do think has merit, and whether you can do that through an appropriate DNAase. So an old thing was extracorporeal, immunoabsorption of anti-DNA antibodies. So doing a form of plasmapheresis where the column, has DNA, and then the circulating, as you do the plasmapheresis every 200 mLs, it passes through the column, and the DNA antibodies would bind to DNA. So I think they had extracorporeal immunoabsorption of anti-DNA was done at some point. The problem is, how efficient is it? Both because, some of the DNA antibodies aren't free in the circulation. I mean, at any one time they may be already bound to their target. They may be in sequestered sites. Having said that, so on the other hand, if you can infuse something that either eliminates DNA, the autoantigen, or eliminates anti-DNA, sure, that would have merit. No, I don't. The first clinical trial I did was La Jolla Pharmaceuticals had a triethylene glycol platform, and on it they placed 4 at each corner, sort of oversimplified notion of the molecule of the drug, 4 oligonucleotides. And the idea is when you infused it, it would bind to like a CAR T cell, but it would bind to B cell that had anti-DNA antibodies, and it would induce apoptosis. So, because there was single signal energy, and if you only give one signal to the B cell without cross-linking, you can induce apoptosis. So we're all saying a lot of the same thing. If you get rid of that B cell and or plasma cell that's making DNA antibodies, that's a target. So that company tried to do it. They never could efficiently lower the DNA antibodies enough that it had met primary outcomes. And this is like 20 years ago. But, fast forward 20 years and now another 10 years, if you have an efficient way of, and I like these because they're more like the CAR. They're very targeted. They are a silver bullet. If you're just getting rid of the B cell that's making DNA antibodies, and the problem with just getting rid of the circulating DNA, that was what I said, that circulating DNA antibody or DNA, that was because there's more DNA being formed because of apoptosis, which the body needs, and then it's not all circulating because it's at any one time it may be bound to a plasma cell, B cell or plasma cell. And so that's all I'm saying. So for it to be effective, you want to get 90% inhibition, and you understand what I'm saying. The drug has to account not only for what's free but what's bound. Right now, I get steroids. Somebody may have DNA.